All right, so continuing with section B. Right, let's continue with section B. The first question here is sensitivity analysis. And here, this is what we are having here. So when I read, Flick and Flock Incorporation has secured a franchise to customize 4 trending Nike trainers: Air Force, Dunk, Blazer, and Horak shoes. The profits per unit, cost per unit, and maximum demand for each customized trainer are provided in the table below. Profit per unit and the cost of maximizing each product is provided in the table below. So this is what we are having here. Air Force profit per unit is 65. So profit per unit for Air Force is 65. Per unit for Dunk is 48. For Blazer is 72. For Hierarchy is what? 67. Now cost per unit for Air Force is 52. For Dunk is 38. For Blazer is 55. For Hierarchy is 49. And then maximum demand for Air Force is 95. For Dunk is 66. For Blazer is 54. For Hierarchy is 40. Right? So here, each trainer requires different amounts of raw materials and labor hours for customization. The company has 238 kilogram of raw materials and 120 hours available with a total customization budget of 55,000. The resource requirement for customizing each trainer are Air Force 4 kg of raw materials and 2 labor hours per unit. Dunk is 4 kg of raw materials and 5 labor hours per unit. Blazer is 3 kg of raw materials and 3 labor hours per unit. And Hierarchy is 5 kg of raw materials and 8 labor hours per unit. Additionally, customization of Air Force should be twice the customization of Blazer, while Dunk must be 3 times the customization of Hierarchy. The customization of Air Force and Dunk should not exceed 50 trainers. The goal is to determine the optimal number of trainer to customize in order to maximize total profit, while considering customization costs and resource limitation, maximum demand, and the additional customization conditions outlined above. So first, they are telling us to present a summary of the above customization to reflect the linear programming solution. Right, so let me give you some trick here. So the trick I'm about to give you here is that you see that in the answers or in the question that you're having, or maybe you might be having during your exam, they'll actually take all the objective coefficients out. They'll clear them because they know that when it's here, you can copy. So they'll clear all of them. And then the constraints to some of them, they will clear them. So you just have to be fast, right? And then be smart about this. So we know that in our normal days, so you see, for example, A is actually carrying 13 marks, big marks. So if you're able to do it, so you're able to get your 13 marks, right? So now let's look at this. Instead, we should present our this thing, right? So A, we know our first this thing what we normally do. Let X1 represent Air Force. X2 represent Dunk. VDANQ. X3 represent Blazer. X4 represent the hierarchy or something. Right? So this is what you're going to do. This can give you that half or quarter. It's still max. So you do this and you move on. We are still continuing. Now remember our sensitivity analysis normally have what? Max Z. Here we are trying to maximize profit because that's what the question said, right? So the question said it here that they are what their this thing is what in order to maximize total profit. So you are maximizing profit here. So now we start with our Max Z. Remember, Max Z only deals with profit, but in the absence of cost, you can put sales there. So some questions will be having the selling price of them, and then they will not be having any cost price. So if in case there's an absence of cost price, you put only the selling prices here. But if there is cost price, you have to subtract each of the selling prices from the cost prices, and then you put the differences here. For selling price minus cost price is going to give you profit. That's what you are going to do. But if the question also have straightforward profits there, profits here, that's what you are going to put here, right? So now Max Z normally use profit. So this is the profit is what you are coming to use. So we are having 65 for the Air Force, and it follows like that. So Max Z is going to be 65x1 plus 48x2 plus 72x3 plus 67x4. So this is what your Max Z is going to be, right? So if it were to be only selling prices, then you're going to just apply the selling prices to this. That's if only there is no cost in the question. But here there is a cost in the question, but they didn't give selling prices and they gave profit. So you only use the profits. All right. Now, after the objective function, we are now going to look at the subjected to constraint. And this is where it becomes a bit problematic. Constraints. This is where it becomes a bit problematic, right? So I will advise that you look at this well. You see the constraint side here. The constraint side here. This constraint. These constraints. Make sure you formulate your constraints to look like this, so that you can be able to track everything. So now, constraint 1 here is what? Customize A. So let's do that. Customize A. What was customize A saying in the question? It is customizing of Air Force. Customize A or something like that. So what was it saying in the question? So in the question, they said that customization of Air Force should be twice the customization of Blazer, right? So customization of Air Force should be twice the customization of Blazer. So X1 should be equal to what? 2x3 because we represented Blazer with x3. So what's following, please be writing so that you can follow up. So this is equivalent to, you can also change this to be x1 minus 2x3 is equal to 0. Just bringing this 2x3 into the equation and then just putting 0 at the back. So it's to the same thing. Now, in addition, they were saying that while rank must be what? 3 times the customization of what? The rank. So whilst rank must be 3 times. So x2 should be equal to 3x4, which is also equivalent to x2 minus 3x4 is what equal to 0. So that's for the customize A. Now let's go to customize B. So customize B. Customize B was saying that the Air Force, the customization of Air Force and Dank should not exceed 50 trainings. They should not exceed 50. So x1 plus x2 should not exceed, so less than or equal to 50, right? So that's what you are going to do, less than or equal to 50. Now let's move on to the next constraint that we are seeing here. We are seeing cost. We are seeing the next constraint here is cost. So now let's write cost. Let me bring it here. So for the cost, we already have the cost on the table, right? They're saying the cost is what, 52 for this, 38 for this, 55 for this, 90, 49 for this. And the budget is what, 55,000. So that's what we are coming to use here. So it is going to be 52 x1 plus 38 x2 plus 55 x3 plus 49 x4, which is what, less than or equal to 55,000. Remember, that's the budget, so they can't spend more than it. Okay, give me some few minutes. All right, so let me continue. Now, we've done the cost already. All right, let's move on to the next one we are seeing here, or the next one here. The next one here is labor hours, right? And this is where it becomes a bit tricky, right? So pay attention here. Pay attention here, right? I would like you to do just something like this. X1, X2, X3, X4, right? Oh, I'm coming. Right, so leave some space, X1 plus, leave some space, kakra, X2, leave some space, kakra, X3. Oh, okay, you let me just do it this way. X3, X4. Right, so the easy way you can get this is that you see it's actually embedded in the question, so you have to find them, right? So what you are just going to do is you are just going to look through and then look for Air Force. What was the labor hours that was attached to it? So Air Force labor hours. So Air Force is X1, right? So let's just skim through the resource requirement for customizing each trainer Air Force, which is what, 4 kg of raw material, and then what, 2 labor hours. So in Air Force is what, 2. So you come, you put it here, 2. Then you check for the other one. Now for Dank is what? Dank is what? 5 labor hours. You come and then put your 5 here. Now, for Blazer here, and it's having what? 3 labor hours. So 3. So you put your 3 here. Now, the next one here is what? Hierarchy. So if you work you, so then that one is also having what? A labor hours of what? 8. So 8 labor hours. You can put it here. You are done, right? So all you need to do is now you have to reframe it now. So this, you are going to get 2x1 plus 5x2 plus 3x3 plus 8x4, right? And then they told us that this is the available distance that they're having for labor hours, 120 hours. So less than or equal to 120. You are done. So simple, right? Now let's do the other one too. You can pause the video, and because of this, you do the other one, right? So the other one is, the next one is raw material. We're having raw material here. So raw material, I'm just writing it right. So you can do the same x1, x2, x3, x4, so that you don't get confused. So the same thing, just skim through and then look for Air Force, what raw materials was allocated to it. So Air Force is having what? Air Force is having what? 4 kg of raw material. So 4 kg, 4, 4. Now the next one. Now the next one, which is what? Dunk is what? Having what? 4 kg, also 4 kg of raw materials here. So 4. Now the next one, which is Blazer, is having what? 3 kg of raw materials. So 3. Now the next one, which is Herak, setting, it's having what? 5 kg of raw material. So 5. Then you are done. So you now write it well, 4x1 plus 4x2 plus 3x3 plus 5x4 is less than or equal to 238. Because the 238 is what they said, that's the available raw materials that they are having. 238, yeah. Right. So basically, that's up to this point. Now, these are the demands, right? The demand for Air Force, Dank, Blazer, and Hierarchy. So you just have to, you can also put the same thing. The demands are for Air Force demand. So it was such that X1 is less than or equal to 95, because that's what they said. And then Dank is such that X2 is less than or equal to 66. Remember, the demands are here. The demands, the maximum demands are here. So I'm just putting the same thing there. Then the next one is Blazer. X3 less than or equal to 54. Then the other one na me huni way no. Spelling the kwa ya na mirror so if X4 is less than or equal to 40. So just the same thing. Now you can add your non-negativity constraint, which says that X1 x1, x2, x3, x4 is greater than or equal to 0. Then you are done with the first part, which is the A. Now, since you are done with A, the rest is actually easy and straightforward and peasy and jeasy, right? So let's look at B. B is saying that what is the recommended optimal mix for flock and a flick and flock, right? So when we scan through here, now this question, we are going to use this sensitivity report to answer that. So the final values here are the optimal values, right? So you are going to say that the recommended optimal mix for flick and flock is 50 x1. So they have to what? Train 50 Air Force. So 50 for Air Force, then 0x2, then 7x3, then 0x4. So you just have to write this in English. If I write Brofun baby, so you just write the recommended optimal mix for flick and flock is to train 50 Air Force. I used to customize 50 Air Force, 0, what's this for X2? X2 is for X2 is Dank. So 0 Dank, 7 Blazers, and 0 Hurak to setting. So you have to put it in English, right? All right. So let's go to C. C is saying that which resource will you recommend? It's supposed to be flick and flock to increase and why. So now you come to the constraint. This question is asking you from the constraint. So you check the constraint that have what? The highest or positive shadow price. There is a shadow price here, right? So looking at it, you can see that this is the one that is having what? A natural positive, like the highest shadow price here, right? But if possible, you can also include this. But this is what? A customization, right? So you can also include it. So you recommend that. So this English you have to write. You recommend that flick and flock should customize should increase customize B and also labor hours, right? Because increasing it actually increases profit. So what this basically means is that whenever they increase labor hours by 1 hour, they are going to get $24 profit. And whenever they increase customize B by 1 unit, they are going to get what? $17 profit. That's what it means here. So you are going to write that you recommend that they increase the labor hours constraint and also they increasing the customized B constraint. All right. So now they are saying that what will be the D is saying that what will be the total profit yield for the optimal mix in dollars, right? So now the profit for the optimal mix in dollars is just you putting this in the maxi. Remember here we said that it's supposed to be what? 50x1, 0x2, 0 for x2, and then 7 for x3, and then 0 for x4. So we put the same thing in our maxi. Remember our maxi was 65 x1 plus 48 x2 plus 72 x3 plus 67 x4, right? So now we had what? The final values 65. X1 was what? 50. So you put it in there. Plus 48. X2 was what? 0 for the final value. Now move on. 72 into brackets. We had, I think, 5 to be. Okay, we had 7 to be X3 plus 6, 7 into bracket 0 for X4. So you do the same thing in here. And with this, we are going to get our profits to be 3, 7, 5, 4. So you see that the total profit, what's the profit that they were asking? The total profit yield for the optimum is what? 3,754. Then you move on. Now E is saying that determine all the binding and unbinding constraints. So E. Now the binding and unbinding constraint, you can just create a table. You put binding here and non-binding here. So for the binding, what happens here is that you have to check on the constraint side of the sensitivity analysis and compare what you have. So you see what they've claimed here as the right-hand side constraint. What they've claimed here. I mean this, like all of this. That's why I'm saying that as you are watching the video, then you are writing whatever we are doing down, right? So you see that this right-hand side constraints is what we are actually having in our formulations here, right? So at the back of the equality sign or the equality sign, those are the hand side constraints. So that's why they've cleared them, because if they know that if they don't clear them, you actually copy. So they've cleared them. So you just have to come and then write them yourself there, maybe on your question paper, right? So we have 0 for customized A, which is already there. You have 50 for customized B, 55,000 for for costs. We have 120 for labor hours. We have 238 for raw material and the rest. So we are just coming to put the same thing here, right? So now let's write the same thing in here. So customize B, we had 50, right? So let's put the same 50 here. Oh, 50. And then we had 50. Here. The screen has started messing up. We have 50 here. Then cost we have 55,000. Then labor hours we have 120 according to our constraints that we computed. And raw material, we have 238. And the rest there, they are there. So now for us to know the constraint, the binding ones, you have to compare the left-hand side to the right-hand side. So now in this particular session, I'm going to take the binding ones. So the ones that the final value is equal to the right-hand side, right? So the final value here, we are having here to be 0, and the right-hand side to also go what? 0. So it's what? A binding constraint. Then B2, we are having final value to be what? 50, and here to is 50. So it's what? Binding constraint. For costs, we are having 29,666. Hey, 2,966.67. And we are having 55,000 as the right-hand side constraint. So what? It's non-binding. Then labor hours, you're having 120 here, and we're having 120 here. So it's what? It's binding. Then raw material, we're having 220 here, and then 238 here. So what? It's non-binding. Air Force, we're having 50, 95 here. Non-binding. Dunk and this non-binding. This and this non-binding. This and this non-binding. Right, so we have these three as binding and the rest as non-binding. So we're going to put the same thing there. Then we have labor hours as binding. We have customize B. We have customize A. And then the non-binding, we have cost. We have raw material. We have Air Force demand. We have Dunk demand. We have laser demand. We have URAG, then demand. Right, and these are all the non-binding, and we have what's the binding. Right, so let's move on. The other part is what is the implication of increasing labor hours by 22? So now, remember that I said here, or I explained here, that labor hours is having what? A shadow price of 24, meaning that when you increase 1 hour, when you increase this labor hours by 1 hour per, we are going to get a profit of 24. So that's the same way. Here, they are increasing it by 22. So if we want to get the implication, we have to multiply this 22 by the 24 and then know the profit that you are going to make, right? So now, in E, we are going to say that increasing labor hours by 22 would increase profit, profit by 528, which is into bracket 22 times 24. Right. Then you are done. Now, I think here we are done with this question. Yeah, okay, so we are done with this question. Now let's quickly move on to question 2. So question 2 here, A, is a paired sample question, which is also under hypothesis testing for two population. So for paired sample, we normally use it to check whether there has been a difference between the same kind of situation before and after some particular incident. So something can be that most of the ladies actually sometimes take bodybuilding drugs. So they want to check whether their body has actually increased, or their body size has actually increased, or their ass size, sorry, their distance has actually increased, right? So that's the same way you want to check whether you want to check your weight before you taking the drug and then after you taking the drug. Has there been any increment in your distance, right? That's the same thing here. That's what PET sample is actually used for. So sometimes too, firms will actually maybe what they will do is, first of all, they will check their sales and then they will bring in some influencer and see whether the influencer can actually boost their sales. So they check their sales before bringing the influencer, and after bringing the influencer, right? Has there been any increase or increment in sales or in profit? Yeah, in profit, then that's what we normally use paired sample for, right? So now this is the question. The football team introduced a new strength and conditioning training program aimed at improving player stamina and performance. To assess the effectiveness of the program, the coaching staff measured the average distance covered in kilometers by first 11 players in a match before and after implementing the training program, right? To improve the performance for the second half of the season. So the first lesson is this, the second lesson is this, San Kwakosi, Kosi 11. Right. Now, they are telling us to what? First, develop an appropriate hypothesis to test the effectiveness. And this is easy, like peasy and jeezy. So question 2, A. Now, the null hypothesis will be such that the noun nomenclature is such that mu d is equal to 0, meaning there is no difference, and then HA is such that mu d is not equal to 0. Right, so meaning that what there is a difference in the training, right? So that's the same thing here. So now that's the A. Now let's look at something. II is saying that indicate the test statistics that is appropriate for examining this effectiveness of the program. So the test statistics that we normally use to do this B. Is T test statistics. So you can write the type of test used for uh, check appropriate for examining this this thing is T test statistic. Now the C. I. I is saying that given your answer in B, conduct a test to the significant effectiveness of the program. Use 5% significant level using the critical level approach, right? So now, before we can compute this, we have to find the difference, right? So we have to find DI here. So in exams, you can also bring DI here. Then DI is basically after minus before. So let's say, let me put A here, A, let me put B here, B. So DI is going to be B minus A, right? So that's what you're going to do. 10.1 minus 9.2, 9.0 minus 8.5. That's what you're going to do. So the after minus before, after minus before, after minus before throughout. So we are going to get 0 0.9, 0 0.5, 0 0.8, 0 0.5, 0 0.6, then 10 minus 9.4, 0 0.6, 0 0.6, 0 0.8, 0 0.6, 0 0.7, and then 0 0.7. Right. Now, with this, we have to sum all of them. So add all of them, and then we are going to get 7.3. Now, we have to also find D bar. D bar is going to give us this sum divided by 11 because there are 11 sample sizes here. It's going to be 7.3 over 11. Right. So that's the same thing here, 7.3 over 11. You get it. Then we are going to get 0.66. Right. Now that's what we are going to use. So we are going to use this. You can write it down and then this in our computation. We are just going to use this sum in our computation right now. Hey, this D bar. Right. So remember that for the paired sample test, there is a formula. Tn minus 1 is equal to D bar minus mu D all over standard deviation all over root of n. Most of the exams, they'll give you standard deviation. If they don't give you to, you have to look for it yourself. But when they see that the time is actually not reaching, and so on, they'll bring the standard deviation. But in this particular question, they give the standard deviation, so we are going to go according to it. Remember that the mu d is approximately equal to 0. The reason why it's equal to 0 is because that's what the null hypothesis was saying. It was saying that mu d is what is equal to 0. There's no difference. And here is saying that there's a difference. So that because of this, we actually make the formula simple, and then the formula will now look like this. D bar over S d over root of n, right? So that's how it is going to look like. So this is going to be a Tn minus 1 is equal to d bar over sd over root of n. So we are just going to put everything in there again, right? So this formula, the d bar that we computed was 0.66 all over. The SD was given in the question. SD was given here 0.3165. So you can use that one 0.3165 all over root of n. N here is what is 11 because they took 11 sample size. Then in all, pata, we are going to get 6.9162. This is approximately 6.916. Now, we draw a bell shape. Right. And then you see it is Tn minus 1. And because we are having what? An equal to sign, we are going to have two tail tests. So we are going to find our degree of freedom, which is what? N minus 1. N is what? Is 11 minus 1. We are going to use 10. And then our alpha is what? 0.05. But because it is 2 tail, we are going to divide it by 2. Now leaving 0.025. So we are going on the T table to find this, right? And then plug it here on our bell shape. So we go on the T table right now. That one, I don't know how to use the calculator to do it, so we have to come and then look for it. So on the T table, there's the T distribution. T. They are going to look for 0.025 here, and then reduce it towards 10. So this is coming to end here because this is in. Right. Normally, paired sample normally have two tail. We'll keep that. You can keep that in mind. So it's a 2.228. So come and write this thing 2.228. 2.228. So anything that falls within here or here is what? Rejection. Right? So now we had 6.9162 is still the same. And we can see 6.9162 is greater than this 2.228. Right? So it falls within here. 6. So meaning that it is what? It is in the rejection. It's in the rejection region. Right? So this actually is trying to say that. Then I think, did I do something different yesterday in class? No, I think the conclusion, so here, they are doing what? Rejecting HO. So the decision is The decision is what? Reject HO. Then the conclusion will be that conclusion, you can write it, bro, but I'll say it. But so you see the now was saying that mu d is equal to 0, meaning that there is what? There is no difference. Whilst HA is saying that mu d is not equal to 0, which means there is a difference. So now because we've rejected HO, we are going to go according to what HA is saying. HA is saying that what there is a difference. So we are going to say that there is a significant difference in training after, what did they do, Campo? They were saying that so there's a significant difference in the kilometers, right? Which actually is trying to say that so there's an improvement. So you are rejecting HO. And then this thing is that the conclusion will be that there is a significant difference in the kilometers covered by the players before and after the new training at 0.05 significant level. You have to, we can pause and rewrite it, play it again, and then listen to it, or because when I write it, it's a bit wasted time, so you can add it to it. So normally what I do is that I read a question, what the question is asking us, and then I use it to what? Conclude. So you actually have to conclude based on what the question is saying. All right, so we are done with A. Let's move to B. B is saying that a researcher wants to compare the mean fasting blood glucose level of pregnant women with gestational diabetes in two different regions of Ghana. In region A, a random sample of 50 women has an average fasting blood glucose level of 105 mg with a standard deviation of 15. And in region B, a random of 60 women has an average fasting blood glucose level of what? 95 mg with a standard deviation of 12. So they are saying that at 5% significant level, is there a significant difference in the mean fasting blood glucose level between the two regions? Assume the population are normally distributed, right? So now, this is actually, whenever you see difference, then it's basically what? Two table test question, right? This is also a hypothesis question. So let's deal with it fast. So 2B, right? Now let's define some of the these things that they were asking in there. Now the question had what? The mean for the first one, which is what? 105. Then the standard deviation for the first one, which is what? 15. And then N for the first one, which is what? 50. Now, we also have X2. Then you have 98. You have the standard deviation for the second one is 12. And then the sample size is 60. Right? So basically the same thing. You just put these codings down, and then once you put down the formula, you'll be able to go. Right? So I I was asking us what? Develop the hypothesis test. So I have to develop the null and alternative hypothesis, right? So the null hypothesis here will be that HO is such that U1 minus U2 is equal to 0. And then HA will be such that U1 minus U2 is not equal to 0. This is going to be the null and alternative hypothesis. Right? So here is saying there is no difference, and here is saying there is a difference. Right? So I'm sure that maybe the previous question I just solved, I said something different concerning the conclusion in class yesterday. But I think I've corrected it. The drew on my brain. All right, so this is the null hypothesis. Now let's go to what the II is saying. II is saying that compute the z-test statistics, right? So now this is the z-test. The z-test has this formula. Z is equal to, because it is what? Two population, hypothesis testing for two population, it is going to what? X bar 1 minus X bar 2 minus, to brackets, U1 minus U2 all over the root of the first one over N1 plus U2 so the first standard deviation squared and the second, and because the first standard deviation squared over N1 or the sample size of the first one over plus the standard deviation of the second one squared over the sample size of the second one, right? So now, because now hypothesis was saying that U1 minus U2 is equal to 0, this will be cancelled out, right? We won't actually do it because it's equal to 0. We are only going to do it the X bar 1 minus X bar 2, right? Like that. So now let's continue. So now the sample size, the mean of the first one is, the sample mean was what? 105 minus 98 all over root of 15 squared over 50 plus 12 squared all over 60. And we are going to get 7 over 2.627, and in total we are going to get 2.67. I've rounded it, right? It's Ankabe 2.665, but I've rounded it, right? So now we look for this on the Z table. Remember, I told you that if the question is silent, you use what? 0.05. Let's check whether, okay. So we've computed the test statistics, right? The Z test. Now here they are telling us what to determine the critical value and make decision. So now we are going to do it this way. determine the critical value, right? We are using 0.05. That's for alpha. Alpha no cry. Alpha hour. Right. So now, because it is a two-tailed test, you have to divide alpha by 2. So it is going to be equal to 0.05 divided by 2, and we are going to get 0.025. Right. So now, let's draw a bell shape. Right. So the thing is that you can go and then look for 0.025 on the Z table and then look for their coordinate, but that will actually take a lot of time. So what I would want you to do is just bring the 0.025 here. Right. And then what you are going to do is you are rather going to check the 2.67 on the Z table and then compare it to this one. So I've told you how to use calculator to do it, right? So let's continue. So shift, because we've done some already, shift 1, 5, 1, and it was 2.67. 0.9962. So you see that the Z is different as compared to the T and the F and the likes, right? So you have to take key note of this, right? So this is what 0.9962, and it is around this side. Right. So this is actually having what? It's actually in the what? In the rejection region, right? So the first one is saying that there is a difference, and the second is saying that there is no difference, right? So now let's check the question again. So our destiny will be that IV rejects HO. Right. And then because rejection is in the what? Is in the difference region. So conclusion is conclusion will be that there is a difference between the glucose levels. Were they asking of glucose? Okay, there is a difference. There's a significant difference in the mean fasting blood glucose level between the two regions at 5% level of significance. So that's what you're going to write. So the decision is to reject HO. And the conclusion is that there is a significant difference. There is a significant difference in the mean fasting blood glucose levels between the two regions at a 5% significance level. Then you are done. Do you get it? All right. Maybe I'm sure. I don't know. It is ringing in my head that I said something different yesterday. Right. So if I said something different yesterday, yeah, sorry. I'm just saying I'm my break because I was up on my feet more than 4 hours. So Just an also count. All right, so we are done with question 2. Right, let's go to question 3. Okay, so question 3 is on correlation and regression. All right, so let's do that. All right, so this is where it gets a bit technical, but you just have to pay attention, and I'm sure you'll be fine. All right, so this is what correlation and regression normally do. We use this in finance. So just learn this where we use this in finance, in accounting, in cost accounting, in economics, like in every aspect of our life. And it is very good. It tries to measure how some things move together, right? So it can be that, let's say, in a relationship, right? Does money brings happiness? So we will put money in the relationship and we will see whether there will be happiness in the relationship, right? And when we also track and see whether when there is no money, is there happiness in the relationship? We also do that. And they will see, then they can check whether money and happiness in relationship are positively correlated. That's if there's more money, the relationship is more or less like a happy relationship. And when there's less money, there's more or less like what? Like the relationship is not that I mean who brought family farmers are wed. So what I say? So that's basically what correlation regression is normally used to do, right? So here they are trying to use it to check whether um, an intake of folic acid actually increases the hemoglobin level in our body, right? So here a nutritionist is studying the relationship between the daily intake of folic acid in micrograms and the hemoglobin levels in whatsoever, in pregnant women. When you're pregnant women, the data collected from 10 participants is shown below, right? So the folic acid 255, whatever, up to here. The hemoglobin level is this up to here, right? The hints that they are giving here, they are giving us a hint here. So we will have SSE, SSR, and the likes. But we wouldn't actually be doing a lot of hard work because they've given us hints here. So here they are telling us to find the correlation coefficient, right? The correlation coefficient, you can, if you have this in the calculator, you can use it to get it. But you have this here already. So you won't actually need a calculator to do that, right? So what we are going to do is we take this one, the E and the summation of this, right? So this is it. Summation of X I minus X. Oh, what is it there? X bar. X bar. All times Y minus Y bar. Right? We divide it by N minus 1. Then we get our coefficient of variation, right? Or covariance, right? So that's what we are going to do here. So here in the question, this hint gave us an answer of 403.25. So we are going to do the same thing here. 403.25. Then we are going to divide it by n minus 1. The n here, the sample size they took here is what? 10. So 10 minus 1 is going to give you 9. So in all, we are going to get 44.81. This is because I've rounded it. Right, I've rounded it. Now, this is what we get for the coefficient or covariance, right? So if we now want to get the correlation coefficient, it's going to be the covariance, which is the correlation coefficient is our covariance over the standard deviation of the first one times the standard deviation of the second one. So when we go forward, the covariance is what? 44.81 all over the standard deviation for the first one is this. This is standard deviation. This is the variance. They only computed the variance here. So you have to make sure you change it to standard deviation. And this is also the variance here, right? So we have to change all of them to standard deviations, right? So now changing it to standard deviation, we are going to have the first one to be we're going to have the first one to be 3 to 6, 6 to 0.5. Because the variances are in square. If you want to change them to standard deviation, you put them in the root. And this is what we will get. We are going to get 180.73. Right, that is for what? 1. Now, the standard deviation for the second one is also going to be the root of 5.761. Right, so the same thing. We put the same, so now we've gotten them. This one is going to give us 2.40. We put the same thing here. So 180.73 times 2.40. And this is going to give us a total of R is equal to 0.1033, which is equivalent to 10.33%. So the 10.33% is the answer for the first side. That's why it is what? A whooping 5 marks. Think it's easy for you to get a 5 marks? You have to do a lot of hard work. Now, the second part is there a linear relationship between the hemoglobin level and the folic acid intake? So they are just trying to ask you that when you take the folic acid, does it increase the hemoglobin level? And that's what we are coming to look at here. So correlation and regression also have its formula for finding this, right? So it also uses the t-test statistics, right? Now, the t I think is it B or I? Right. T is going to be equal to R, which is the correlation coefficient that we solved up there, all over the root of 1 minus R squared all over N minus 2. Right. So we put the same thing in here. 0.1033 all over 1 minus 0.1033 squared all over N minus 2 is what? I think we had 10 as the N minus 2. And then we are putting all of this in this. To remember the square root sign. Right. Now, this is going to give us 0.8353. So now we move on to drawing our bell shape again. Bell need a draw baby. Right. And this is going to be a two-tail test. Right. And then normally the HO, sorry, will be such that I think it's R. I'll revert on it. So this is what we are going to get. And we have to trace this on the table, right? So what we are going to do is, I told you whenever they are silent on the significance level, you have to use what 0.05, right? But this is a two-tail test, so we have to use what 0.025. Let me check the question again. So now alpha is going to be 0.05, but because alpha is divided by 2, you are going to get 0.025. Right, so that's what we are going to trace. Our degree of freedom is going to be, here is going to be n minus 2, so 10 minus 2, which is going to be 8. You get it? So we go to our T table. Our T table, then 0.025, and then 8. So this is what we get. This this, right? So it is going to be what 2.306. Please don't forget to vote for Emmanuel Andoh, okay? So 2 points. Right. Now, we are now going to compare what you computed up there, the 0.8353 to this one. We can see that the 0.8353 is less than this 2.306, right? So it is around here. You can say it's around here. So it is in a do not reject region. So here is the reject region, and here is what? In the do not reject region. Right. So now we can conclude that what? Do not reject HO. Right. And the conclusion is that there is a linear relationship between the folic acid intake and the hemoglobin level at 0.05 significant level when you are done, because that's what the question asks you to do, right? So there is a linear relationship between them, right? Then we are done. 7 marks. Let's move on to the next one. Next one is saying that compute the estimated change in the average value of the hemoglobin level as a result of a change in the folic acid intake and interpret your answer. Right? It looks strange, but it's not strange. So I. So if you want to know the difference, then it means that you are trying to find BI. Remember, the equation is actually Y is equal to BO plus B1, right? X. Oh, I think when I'm screen I started hard. Right? So Y is equal to BO plus B1X, right? Now, we have the dependent and independent variable here, right? So Y is dependent on this, but X is actually standing alone, right? So we are actually trying to compute for this B1, and it has its formula, right? And they've given us some of the distance already in the question, right? They've given us some clues, some hints in the question. So we are going to use that. So the clue here is to use. Sorry, that was a small glitch. Okay. So you are just going to use this over this, and then you get it, right? So let's do that. So if you want to get B1, it is going to be my keyboard is worrying. It's my keyboard. My screen has started worrying. right? So this is what we are going to use. And in the question, the first one is what? 403.25 as the hint. And then all over. The second one is 3266.2.5. So we are going to get 0.012 3, right? So that's going to be the estimated change. That's going to be our estimated change. So you can say that for every 1 unit intake of folic acid, hemoglobin levels are expected to increase by 0.0123 units on average, holding all other factors constant. So you can write that English in addition, right? So let's move on to also solving for BO, right? So in all, this thing actually looks like in a cons, or I think in other distance, we can say that this is the total cost and the BO is the fixed cost, and then the B1 times or B1X is the total variable cost, where B1 is the variable cost per unit, BO is the total fixed cost, and then the Y is the total cost. So that's the same thing here. So now we've gotten B1, and then we are coming to now look for BO. If you want to get BO, what we have to do is we just have to take one of the figures we are having in the question, replace Y, and then X, and then remove. Look at what we are coming to do now. So let's use the folic acid to be X and the hemoglobin level to be Y, right? So here is the total cost. Here will actually be what? The variable, the per unit, the X's, right? So this is it. So now let's do it here. So let me just take 255 and then 11.2, 11.2. So Y, let me close this. I don't know, but I tried to reset my Microsoft keyboard, but I'm fast. So let me just use a notation here. So remember our distance, what? Y is equal to BO plus B1X, right? Now let's just take this first one and this. So this is the total. This is going to be X, and this is going to be Y. So Y here is what is going to be 11.2 is equal to BO, we don't know. That's what we are looking for. Plus B1, we had 0.0123. And then now X is what? 255. Right. So now what we are going to do is, if we want to get BO, and we have to multiply this by this and then move it at the back of the equal to sign. So we are going to get 11.2. This is positive. When it's because it becomes negative, so minus. We are going to get into bracket 0.0123 times 255 is equal to B. Right, and then we are going to get BO to be equal to 8.0635. So this is trying to say that the estimate value of hemoglobin when overall folic acid intake is 0, like when don't take any folic acid, is 8.0635. Right? That's why I said it is what equivalent to the fixed cost, which is that if you don't even produce, this is the cost you are going to incur. So that's the same thing here, right? Okay. So let me move on. So now they are telling us to specify the estimated linear equation, right? So the estimated linear equation, that's what we just solved. So it is going to be y is equal to the first cost 8.0635 plus 0.0123x. So this is what's going to be the estimated linear equation, right? Now, the VI is saying that, okay, that's the last one. The VI is saying that compute the R square. R square is the coefficient of determination. And they've given you some hints here. Remember, the R square is actually sum of square regression. The formula is sum of square regression, SSR, all over total sum of square, SST, right? So now, let's try and then solve for SST. SST is equal to SSE plus SSR, right? And this, for example, should have been the formula for SST, but they didn't square it. So SST's formula is going to be the summation of y minus y bar squared, right? And SSE is going to be summation of y minus y estimate plus summation I'm sure say afifa ebe fa we need to because regression no won't be we any kada. Y bar squared. Right. So now you see this. Oh, here too is supposed to be squared. This should have been squared here, but one person tricky crazy. So you didn't bring the square, right? So you are supposed to square it now. And they also gave you this one, the SSE. They didn't give you SSR. So you have to what? Subtract the SST. Because when you change subject, it is going to be, if you want to get SSR, it is going to be, if you want to get SSR, it is going to be SST minus SSE, which is going to be SSR, right? But they've only given you see, they didn't give you SSR, so you have to subtract and then get SSE, SSR, sorry. So now SST is going to give you, I'm continuing from the top here, I'm doing it on the paper. So SST is going to be what? This squared, 5.76 squared. So 5.761 squared minus SSE is here, right? So they've already given it to you in squared already. So here's our best square. So minus minus 0.7824. And you are going to get you are going to get, so you square this before you subtract, and you are going to get 33.189. So 33.19. You can put it like that. Right. So now we've gotten the what? SSR to be what? 33.19. And we already have SST to be in here already. Right? SST is here. So what we are going to do now is we are going to do it this way. No, subtracting them in any way. We'll be getting 32.406 or so. Right, so 32.41. Now, R square, as I said, is what? SSR over what? SST. And we've gotten SSR to be this, right? So we are going to get 32.41 all over. When we squared this, we had 33.19. 33.1. So now, this is how it is going to look like. So 0.9765. So it is going to be equal to 0.9765. Right, so according to the interpretation, what we are going to say is that so approximately we can change this to 97.65%. So what we are going to do, or how we are going to interpret this, is that 67.65% of variation in folic acid intake is explained by the variation of the hemoglobin level. Na yapon. So this is where we end this video. I know that this video is lengthy, but kindly bear with me because when you understand, you have to explain some concepts, right? Thank you very much for your time. Don't forget to like this video and also subscribe to the channel for more. Next semester, there are many more. Why? Bye. Please don't forget to also vote for Yooku Andoh as the EGSRC treasurer. Okay, when the time is due. Thank you very much.